Today we are going to learn about the quadratic inequalities. We know that a quadratic expression is like x square minus 4x minus 5. This is a quadratic expression. Quadratic equation is x square minus 4x minus 5 is equal to 0, and quadratic inequalities like x square minus 4x minus 5, so we can use either greater than 0 or less than 0 or less than equal to 0 or greater than equal to 0. The difference in this is, for the expression x square minus 4x minus 5, it can only be factorized. So when the question is there factorized, it will be so its factorization will be x, and this is 5 and this is 4. So we write 5 times 1 is 5. 5 times 1 is 5. And this is minus 4. So this is minus 5 and plus 1. So these are the factors of this. Now for an equation, it is in this form: x square minus 4x minus 5 is equal to 0. It means x minus 5 and x plus 1 is equal to 0. So this means x is equal to minus 1 and 5. So these are the solutions. So it is having two solutions. Now if it is a quadratic inequality, so its solution is values of x, or the set of x. It will be having so many values. For example, this question is, if I draw the graph, this is minus 1 and this is 5. So these are the two values of an equation. But if it is an inequality, it's written in this form: so if it is x square minus 4x minus 5 is greater than 0, then we have to solve it by the method of solving an equation. Find the critical points. These are the critical points: minus 1 and 5, and it is greater than 0. It means y is greater than 0. Generally it's fx or y. So it means whatever is the value above this line, because above this line y is a positive, so it is greater than 0. So these are the values and these are the values. That is the solution. So let's take an example. Now let's take a question. Let's take the same question and try to find out. Question is, so let's have this question: find the set of values of x. Set of values of x we can find only when it is an inequality. So this is the highest power is 2, so it's a quadratic inequality. So first we will try to find critical points where the curve is crossing the x-axis. we have x square plus 7x plus 12. We solve it as an equation. So this is 12, so its solution will be, its factors will be x square plus factors of 12. 12 is equal to 1 multiply 12. This is 6 multiply 2. Then this is 4 multiply 3. 12 plus 1 is 13. 12 minus 1 is 11. 6 plus 2 is 8. 6 minus 2 is 4. 4 plus 3 is 7. 4 minus 3 is 1. So now we can see here we have 7 here. So this is 4 plus 3. So instead of 7 we will write 4x plus 3x. So it will be 4x plus 3x. Had there been 13, we would have written 1x plus 12x here. So plus 12 is equal to 0. The only thing we have done is this 7x we have written as 4x plus 3x. Now we'll make these two terms together and these two terms together. So we take x common here. This is x plus 4. And here 3 is common. So we have x plus 4. If you are doing it correctly, you will always find the terms in the bracket will be same. So now x plus 4 is common. So remaining is x plus 3 is equal to 0. So our critical points, x is equal to minus 3. Equate x plus 3 is equal to 0, so x will be minus 3. And x plus 4 is equal to 0, x will be minus 4. So these are our critical point. Now here we know that a is greater than 0, so shape of the graph is this. So this is an upward graph and passing through negative 3 and negative 4. Now our inequality is this is greater than 0. So we can interpret it as y is greater than 0, greater than equal to. So y is greater than equal to 0 is this area above this area. Above the x-axis, y is all positive and greater than 0. So our solution will be all this. So it means this is greater than equal to. So our equation will be this one. This is the solution. And our equation, this one is. So the solution is x is less than and equal to minus 4 and x is greater than equal to minus 3. Let's take another example. Find the set of values of x for which x square minus 5x is greater than 0. So this is x square minus 5x is greater than 0. For critical values, we have x square minus 5x is equal to 0, x common. We have x minus 5 is equal to 0, so values of x will be x is equal to 0 and x is equal to 5. So on the number line, if this is 0, this is 1, 2. So the critical points are 0 and 5. So the graph will be passed through 0 and 5. But now as it says, this is greater than 0. So greater than 0 is the top part of x-axis. So we have this solution, this one, and we have this solution. So the answer will be x is, we can write x is less than 0 and x is greater than 5. So we can write this solution. Use set notation to describe set of values of x for which 4x square minus 3x minus 1 is less than 0 and 4x plus 2 is less than 15 minus x minus 7. So now for this, let's say we have 4x square minus 3x minus 1 is equal to 0. So that is, we have to factorize it. So we can say 4x square, 4 times 1 is 4 minus 4x plus x minus 1 is equal to 0. We take 4x common, x minus 1 plus 1 common, x minus 1 is equal to 0. X minus 1 is common, so the remaining is 4x plus 1 and x minus 1 is equal to 0. So x will be 1 and minus 1 over 4. So our critical points are minus 1 over 4 and 1. So let's say this is our line, and say this is 0, this is 1, this is minus 2, this is 1. Let's say this is our number 9. So the critical points are 1, this one, and minus 1 over 4, that is this one. And as it is less than 0, so our solution is this. This is our solution. Now let's find out this one. So that is 4x plus 8 is less than 15 minus x plus 7. This will become plus. So 4x plus 8. Let's take all this side. Minus 15 plus x minus 7 is less than 0. 4x plus x will be 5x. 8. This is minus 15 and minus 7 plus 8. This is plus 7. This will become minus 7. So minus, this is 8. That is 14 is less than 0. So 5x is less than 14. X is less than 14 over 5. So this one is roughly this one. So this is the value. Now this is saying AND. AND means that is common, this and this. So which values are satisfying both? Only these values where the lines are common. So its solution will be x such that x is greater than minus 1 over 4 and x is less than 0. So that is the solution set of this. Now imagine if our solution is like this. This is a number line and we have, say, minus 3. So this is our number line. Suppose the solution of the first part is this, minus 1 to 3, and I might say the solution of the second part is this. Here this complete is common, but here only a partial is common. So our answer would have been this area only. If the word is AND. AND means a common portion. So only this one. So the solution would have been x such that x is greater than minus 1 and x is less than 1. This would have been the solution for this if it is AND. Had it been OR, so OR means this complete, this side up to here. Let's take an example. Now the next question is, use the set notation to describe the set of values of x for which x square minus 2x minus 3 is less than 0 and x square minus 3x plus 2 is greater than 0. So in both are the quadratic, so we have to find the critical values. So for critical values of x, we have x square minus 2x minus 3 is equal to 0. So it means the factors we can write directly here. 3 times 1 is 3 and minus 3 plus 1 is minus 2. So x will be minus 1 and 3. These are the critical values, and for this critical value we have x. This is x square minus 3x plus 2 is equal to 0. So we can take x and x. So factors of 2 is 2 times 1 is 2 and minus 2 minus 1 is minus 3. So this means x is equal to 1 and 2. So we have these factors. Let's draw a number line and minus, let's say this is 0, 1, 2, 3, 4, and let's say this side is minus 1, minus 2. For the first one, this thing is less than 0, so the down part of it, minus 1 to 3. This is minus 1 because our graph is coming like this way. So minus 1 to 3 is less than 0. So less than 0 is this portion of the graph. this y is less than 0. So we are going to take this portion of the graph. When we take this portion of the graph, we have this one. That is the solution, -1 to 3. Now this is greater than 0. So let's take it 1 and 2. So this is 1 and 2. This one, and this is greater than 0, so this is the top part. So top part will be this one. This portion. So the value will be this one, this one, and this is 2. So that is a solution. So end means is a common area. So where is the common area? So we have two common areas. The first one is this one. This is the common area, and here from 2 to 3, this is the common area. So here we can see both the lines, here we can see both the lines. So this one is, this is x is greater than -1 and less than 1, and this one is x is greater than 2, x is greater than 2 and less than 3. So the solution set will be x such that x is greater than -1, less than 1, and x such that x is greater than 2 and less than 3. And we have here the union of it, this and this. So this is going to be the solution set for this question. Now the next question is, find the set of values of x for which 8 over x is greater than 2. So for this question, 8 over x is greater than 2. Now multiply both sides by x. So if multiply both sides by x, 8 over x multiply x and 2 multiply x. Now what will happen to this sign if you multiply both sides by? If x is, we don't know if x is positive or if x is, we don't know the value of x. If x is positive, then the sign will remain same. Now what if x is negative? If we multiply negative number, the sign will reverse. So it means we cannot multiply both sides by x. We make sure that we multiply both sides by a positive number. So the positive number is x square, is 100% is a positive number. So we multiply both sides by x square. So that is the main point you have to consider when solving such kind of inequalities. So now this will be 8x is greater than 2x square. So I can write this one as 2x square minus 8x is less than 0. So for critical values, hope you understand this point. This, if I take this side, this sign will remain. The 0 is this side, so 2x square. 0 is greater than 2x square minus 8x. It means 2x square minus 8x is less than 0. So for critical values, we have 2x square minus 8x is equal to 0. 2x common, x minus 4 is equal to 0. So either x is 0 or x is 4. So if we draw a number line, it is 0 and say this is 4, and we draw the graph. It is less than 0. Less than 0 means the down part of the graph. So our solution set will be, so x such that x is greater than 0 and x is less than 4 will be our solution set for this question. So next question is same like the previous one. So now we have 5 over x minus 3 is less than 2. Now we have to multiply both sides by a positive number. So we don't know x minus 3 is a positive or not. But if we make a square of it and it is not 0, inequality remain the same. So this will become 5 x minus 3 is less than 2 x square minus 6x plus 9. So this inequation will become 5x minus 15 is less than equal to 2x square minus 12x plus 18. So let's take all this side. So this is 5x minus 15 minus 2x square plus 12x minus 18 is less than 0. The sign will remain same. So this is minus 2x square, then 12x and 5x is plus 17x minus 18 minus 15 is 33 is less than 0. So I multiply both by negative, so it is 2x square minus 17x plus 33 is greater than 0. So now this is a quadratic equation. Let's try to solve it using a formula. So we have a is equal to 2, b is equal to minus 17, c is equal to 33, and d is equal to minus b square minus 4, a is 2 and c is 33. So d is equal to 25. Now we use the formula for the critical values. For critical values, x is equal to minus b, so that is plus minus root d, that is 5 over 2a, 2 multiply 2. So that is equal to 17 plus 5 over 4 and 17 minus 5 over 4. 17 plus 5 is 22 over 4. So x is 11 over 2. 17 minus 5 is, so x is 3. So now we have the values. That is, say if it is 0, say this is 3, 4, 5, 6. So we have this value. So graph is passing through. It's an upward graph if it is greater than 0. It will pass through here. Not from 6, that is 5.5. Now if it is greater than 0, greater than 0 means the top values. Top values means this and this. This is covering this. So we can say x is less than 3 and x is greater than 6 is the solution. These are the sets of values.